Algebra 2, Unit 8, Lesson 2, and in this lesson, most of it is a review. We're going to solve polynomial functions by factoring. And I've got two terms here, or two phrases that you need to understand. Degree of a polynomial and leading coefficient. The degree of a polynomial is the highest power in a term of a polynomial. So if we had, I'm just going to ignore this for a second, and let's say we have something like x cubed y squared plus 3x to the fourth minus 8x squared y to the first. And that's equal to 0. If I'm trying to find the degree of that polynomial, what I have to do is find the degree of each individual term. And then the degree of the entire polynomial would be the highest of those terms. So this one has a degree of 5 because 3 plus 2 is 5. This one has a degree of 4. This one has a degree of 2 plus 1 or 3. So the degree of the entire polynomial would be 5. Now, the only problem with this is when we have more than one variable, it's not really considered a polynomial in one variable. So when we're talking about degrees of polynomial functions, we're going to be looking at one variable only in that function. That's what makes it a function. This would not be a function because if we tried to graph it, it's not going to be something where the vertical line test will pass. So when we're talking about degrees of polynomial functions, we need to consider functions like this, where you only have one variable. So this is a polynomial function. In order to find the degree of that polynomial function, what we need to look at is which term has the highest power. For this polynomial, the first term, 100, has a degree of 0. Because the variables have all dropped out, that was understood to have a 100x to the 0 power. So since the power of the x term is 0, the degree of this term is 0. For this one, 29 or negative 29x squared, the power of the x term is 2, so that means the degree of that is 2. And for this one, the degree is 4 because the power is 4. Now, so the degree of this polynomial function is 4. And then we also need to consider what the leading coefficient is, because the leading coefficient and the degree is going to help us later in the chapter when we're determining a lot about the curve that this polynomial function would make. So if we're talking about the degree, it's the highest power. If we're talking about the leading coefficient, what we need to do is write this polynomial function in descending order. The highest power, then the next power, then the next, until we get down to the lowest degree. So now, we're going to solve these polynomial functions. And in order to do that, the first thing I have to do is make sure they are in descending order. So I'm going to rewrite it. X to the fourth minus 29x squared plus 100 equals 0. Now, one important thing about the degree of the polynomial is that degree is going to tell us how many solutions your factored polynomial should have. So if this is a degree of 4, which it is, that tells us there are going to be 4 answers. In other words, there are going to be 4 roots, or 4 solutions, or 4 zeros. 4 places that this thing crosses the x-axis. Now understand, if it has any imaginary roots, we've talked about what happens there. If they're imaginary, there's a little loop either above or below the x-axis. They're counted as roots, but they would be imaginary roots, so they never cross the actual x-axis. But when we do the math, we should have 4 answers for this problem. So if I do this one, the first thing I'm going to do is, since that's x to the fourth and my middle term is x squared, that kind of gives me a hint that I need to factor this trinomial like trinomials, but instead of this being x squared, it's x to the fourth. So instead of having an x and an x in my parentheses, I need an x squared and an x squared. And we did this earlier in one of the sections. I don't think we've had any homework on this yet, but we did do an example like this earlier. And then everything else is normal. We're going to say what factors of 100 add to give you 29. 4 and 25 will add to give me 29. So I'm going to put a 4 here and a 25 here. And then this tells me the signs are going to be the same as the middle term, so they're both going to be minus. And so now what I have here is the difference of squares times the difference of squares. Those both can be factored again. So I can say that this is x plus 2 and x minus 2. This one is x plus 5 and x minus 5. If I set all of the factors equal to 0, I'll get x equals negative 2, x equals 2, x equals negative 5, and x equals 5. Now, that's just one way to solve that. There's another way to do that where once you get it to this part where you've got difference of squares, you can go ahead and set each of those factors equal to 0 and solve. And I prefer that method because I think it's a little bit easier. So I'm going to go back to where we had two difference of squares. I'm going to go ahead and set each of those equal to 0. So when I do that, I have x squared equals 4, and I have x squared equals 25. And now, to solve this, all I have to do is take the square root of both sides of each of those equations. Because if I want to get x by itself, I take the square root. Now, the one thing here that you need to remember is that when you put in the square root, you have to put in the plus minus, because it does yield two answers when you put in the square root sign. So x equals plus or minus 2 and x equals plus and minus 5 would be your answers. So we have four answers: 2, -2, 5, and -5. We would expect it to have 4 because the degree was 4, and that's how many we end up with. Now, if you're one of those people that when you put in a square root, you always forget to put the plus minus, I would do it the other way and factor. Okay, but you need to remember when you put in the square root, you have to have two answers, the positive and the negative. All right, looking at this one, a common mistake with this one is people look at that and they say, oh, well, all I have to do is take the cube root of both sides. So if I take the cube root of both sides, what I would have, and don't write this down, is x equals 2. Well, x equals 2 is one of the answers, but how many answers did we say we were supposed to have with this one? Because of the degree of this original polynomial, how many answers are we supposed to have? Not just one answer, we're supposed to have 3. So this tells us right off the bat how many answers we're supposed to have. So if we just take the cube root, we're only going to get one of those answers. So we haven't finished the problem, we haven't done it correctly. So when we have something like this, if it's a cube root, you cannot just take the cube root of both sides. You have to move the 8 to the other side. And now you have to solve this by factoring. And think about what you have here. We've done difference of cubes before, but we haven't done it in relation to finding the roots of a polynomial function yet. We just figured out how to factor it. Now we're going to use that to solve a polynomial function. So if we do that, remember you have two sets of parentheses, one that has 2 terms and one that has 3 terms. It will still be equal to 0. In this section of the first polynomial, or the first set of parentheses, I'll put the cube root of x cubed. So that's going to be x. In this one, I put the cube root of 8, which is 2. In this one, I take whatever I had in the first term and I square it. So that's x squared. The last one, I take whatever is here and I square it. 2 squared is 4. The middle term here is these two multiplied together. So that's 2x. Now remember, this is review. We've done this before. And then my signs, remember, are same, different, plus. This sign is the same as what we started with, so minus. This one is different than what we started with. It's a plus, and this will always be a plus. Now we have two factors. This one is going to have 1 root. This one is going to yield 2 roots because it's x squared. So I set this one equal to 0. I get x equals 2. That is one of my roots. I have to have 2 more roots. Well, if I try to factor this, factors of 4 that add to give me 2 doesn't work. So there are other methods that I have to do this with. I could use completing the square. I could use the quadratic formula. I'm going to use the quadratic formula because that is something that always works. Completing the square always works too, but sometimes the numbers get pretty difficult. So since quadratic formula always works, that's what I'm going to do. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And remember, what's underneath the square root was the discriminant. What's in there helps us determine what type of roots these will be, whether they're imaginary or whether they're real numbers. And so if we plug in, negative b is negative 2, plus or minus the square root of b squared is 4, minus 4 times a times c, and that's all over 2a, which is 2. Then I'm going to do the math to solve it. I've got negative 2 plus or minus the square root of 4 minus 16. Well, 4 minus 16 is negative 12. To simplify negative 12. Negative 12, I can bring an I out, so these are imaginary roots. I've got a negative 2 plus or minus, and I comes out. 12 is 4 times 3. 4 is a square number, so I can bring a 2 out. So I can bring out a 2i We've got the square root of 3 left inside, and that's all over 2. So that means my two roots are -1 plus or minus I square root of 3. That is two different roots because I have a plus and a minus. So I have three roots here. I've got 2 and I've got -1 plus or minus I square root of 3. Now this tells us a lot about the graph. It tells us that it crosses the x-axis at 2, but somewhere on the graph it's going to have a loop that never crosses the x-axis where we have these two imaginary roots. So I've got 3 more examples that we're going to talk about. In the first one, it says x to the 4th minus 10x squared plus 9 equals 0. The degree, it is already in descending order, so the degree here is 4. That means we would expect to have 4 roots. The leading coefficient here is 1. And we'll deal more with the leading coefficient later when we're talking about what the graphs look like. That leading coefficient becomes significant when we're talking about in behavior. So if I factor this, I'm going to do my 2 sets of parentheses. I know I have x squared here and x squared here because that's what the middle term degree is. Factors of 9 that add to give you 10 would be 9 and 1. The plus tells me they have the same sign and they're both minus because that's a minus. I set those equal to 0. At this point, I know I'm going to be able to set each factor equal to 0 and solve. So I've got x squared equals 9 and x squared equals 1. When I take the square root of both sides, this one gives me x equals plus and minus 3. Remember, when you put in the square root, you have to put plus or minus. And for this one, I take the square root of both sides. So that would be x equals plus and minus 1. So my 4 roots are 3 and -3 and 1 and -1. 4 roots is what I would expect because of the degree of the polynomial. I'm going to set this equal to 0 so that I can factor it to solve it. So 6x squared plus 7x minus 3 equals 0. Looking at this, the highest power is 2, so the degree of this polynomial is 2, so that tells me we're going to have 2 roots. We don't know yet whether they're going to be real or imaginary. The degree, or the leading coefficient here is 6. Again, that will be significant when we're talking about in behavior later in the chapter. So the first thing I'm going to try to do here is to factor this. 6 times 3 is 18. Are there factors of 18 that subtract to give you 7? I would say 9 and 2. So I need to make a 9 and a 2. To make 9 and 2 out of 6, 1 and 6 is not going to work because 6 doesn't go into either of those, but 3 and 2 would work. So I'm going to use a 3x and a 2x. 3 times what gives me the 9? That would be 3. 2 times what gives me 2? That would be 1. And then I need to double check, is 1 times 3 equal to 3? It is. This minus tells us the signs are different. And the plus goes with the 9, the bigger number. So 3 times 3 is 9. So my plus goes right there, my minus right here. And I end up with 3x minus 1 times 2x plus 3 equals 0. Now I set each factor equal to 0 and solve. So for this one, I would have 3x equals 1, so x equals 1/3. And here I have 2x equals -3, so x equals -3/2. So my two answers here are 1/3 and -3/2. It's okay that they're not nice whole numbers. Sometimes that's going to happen. When we graph this one, it's just going to cross the x-axis at 1/3 and at -3/2 or -1.5. You're going to move the 216 to the other side and set it equal to 0. Looking at that, that is the difference of cubes. 216 is 6 cubed. So when I do my 2 factors, I have an x here, a 6 here. That squared is x squared. These two multiplied together is 6x. 6 squared is 36. My signs are the same, so that's a plus, different, plus. So if I set each of those equal to 0, x equals -6. Are there factors of 36 that add to give you 6? No, and I've never seen a trinomial that comes out of a perfect cube or the sum or difference of cubes that will factor. So I'm going to use the quadratic formula. Negative b, which is 6, plus or minus the square root of b squared, 36, minus 4 times a times c, which is 36, all over 2 times 1, which is 2a. And then I'm going to solve that. So I have 6 plus or minus the square root of, that is -108. -108, that is, I can bring an I out. Oops, let me bring that. So for negative 108, I can bring an I out. So that's 6 plus or minus I. We're going to have something left inside. I've still got the 2. 108 is 4 times 27. 27 breaks down into 3 times 9. So I can bring a 2 out with the 4 and a 3 out with the 9. So I can bring out a 6. So I have a 6i, and then there's a 3 left on the inside. And then I can divide both of those by 2. So I've got 3 plus or minus 3i square root of 3. So for that one, I did have 3 answers. Negative 6, and then 3 plus or minus 3i square root of 3. And again, it will cross the x-axis at one place at negative 6. And then these two will be imaginary roots where you have a loop that never crosses the x-axis somewhere on that graph. Now, whether that loop is going up or whether that loop is going down, we'll talk about later in the chapter once we get into end behaviors.